We've seen the explanation of how to change a Riemann sum into, or convert a Riemann sum into a definite integral, or vice versa. So now we're actually going to put this into action. All right, so we have example 11, and with example 11, we're charged with turning this limit of a Riemann sum into a definite integral. Okay, so how do you go about it? We know that this is saying there's a lot of rectangles underneath a curve, but we don't know exactly where it is, so we can't put it into the definite integral. And we know the definite integral is going to have the form of the integral from a to b of f of x dx. All right, so we have to figure out how everything matches up. Okay, well, the dx matches with delta x, and we know that delta x is the term over n. We were seeing in the previous video that delta x is b minus a over n. All right, so this is our delta x right here. All right, our last term there that's over n. That's our delta x. So we can start by saying, well, we know that delta x, which is b minus a over n, in this particular case is equal to 5 over n. Okay, so we know that b minus a is equal to 5. Okay, so there's a starting point. We know that there's going to be a difference of 5 units between our two bounds. Okay, now we just need to figure out where these bounds are. What are the actual a and b? Okay, well, if you recall from the previous video, we are plugging this term here, this k term that's in parentheses. That is our a plus k delta x. Okay, so a plus k delta x, that matches with whatever k term you see in parentheses. So we see 1 plus 5k over n. That's all in its own set of parentheses. So it's all one term. So 1 plus 5k over n matches with a plus k delta x. Okay, and now you can kind of see how everything is kind of matching up together. We have the 1, which is separate from the k term. The a is separate from the k term. So the a matches with the 1. Right? In addition to that, we can also see, well, 5 over n, that's our delta x. 5 over n, there's our delta x, and we're multiplying it by k. Exactly what's happening right there. So the a matches with the number that's being added to the k fraction. If we don't see a number added to the k fraction, then that means that a is equal to 0. Because we're just adding 0, we're just not writing it. Okay, but because we have a plus 1 here, that means that a is equal to 1. And if a is equal to 1, we know that b minus a is equal to 5, so that means that b must be equal to 6. So we're getting closer to our answer now. We now know that we have the integral from 1 to 6 of something dx. And the question is, what's the function? All right, well, again, from the previous video, we know that we took that k term and we plugged it into the function. So if we go back to our Riemann sum here, all right, here's our k term. And what are we doing to this k term? Well, we're squaring it. So this k term right here is really our x. Right? We're plugging that into our function. So our function is x squared. Okay. And we're done with that problem. We've got the integral from a to b of f of x dx. Okay. So again, the hardest part is figuring out what a and b are. We know that b minus a is going to be equal to whatever the numerator is of our term at the very end. And we know that a is the number which is being added to the k term. So using those two pieces of information, we can calculate a and b. Okay, and once we get a and b, now we just look at the k term, what's happening to the k term. Oh, in this case, it's being squared, so that's what's going with our function. Now, example 12 goes in reverse, so that's going to be part of the next video, but let's skip ahead quickly to example 13. All right, actually, at this point, if you can, pause the video and see if you can pick the correct answer from the multiple choice, doing the same thing that we just did in example 11. Okay, then unpause the video, take a look at example 13 with me, and after that, we'll move to examples 12 and 14. So if you've paused the video and then unpause it now, let's see how you did. Once again, we can see that delta x is equal to 3 over n, and that's b minus a over n. So b minus a is equal to 3. Okay. In addition to that, we have our a plus k delta x term, which matches with the, I'm going to change the order here since we can change the order when we're adding. That's the additive, the commutative property of addition. So we have 2 plus 3k over n. We can see that the a and the 2 are going to match up. So a is equal to 2, which means that b has to be 5 minus 2. B is 5. All right, so we have that. Try that again. B is equal to 5. So we're looking at the integral from 2 to 5. And that eliminates a couple of the possibilities already. Now we just need to know what's our function. Well, here's our a plus k delta x term. What are we doing to it? Once again, just like before, we are squaring it. So this is our x term, and we are squaring it. So we're going to have x squared dx, which I believe matches with answer C. So if you pick C, great job.